exam preparation. For exam preparation, you can skip these parts, else you can read them. Okay. Now, okay, I'm looking at the experimental arrangement. Okay, what are we looking at? We are looking at the experimental arrangement. Okay, why should we look at the experimental arrangement? Because this question is asked many number of times in the theory exams as well as the practical exam. Okay, practical exam now. We will do this in the lab and theory lo kuda adugutunnaru. Okay, that's why. Okay, what is this question associated with? Okay, he may ask you, okay, given an experimental procedure to determine the wavelength of light using a diffraction grating element, that will be the question. Okay, so they may ask you to use the diffraction grating element to determine the wavelength. Okay, right. I'll give you 5 seconds to observe and tell me. Observe the screen. 5, 4, 3, 2, 1. What did you observe? Okay, how many different devices are being used here? Or apparatus are being used here?
2 devices.
Okay, very good. What are they?
Telescope,
Telescope
collimator.
and collimator.
Telescope and collimator.
Excellent, very good. Okay, from the first and second figure to third, fourth, fifth. Okay, what is different? Is 1, 2 similar to that of 3, 4, 5? Or do we have some difference over there?
Telescope is moving at an angle 90 degrees.
Excellent. Okay, no problem. And is there anything else?
I guess there's a screen in between or something.
Right, that is the grating element, the rectangle. Okay, a rectangle rod-like thing that is placed. Okay, that is the grating element. In the first and second, you have a circle without that rectangle. Okay, and in the third, fourth, fifth, you have that rectangle. That rectangle is nothing but a two-dimensional representation of a grating element. Grating element. Okay, very good. And what about the circle? What about the circle? What is that? That circle is your circular scale. Okay, that circle is a circular scale on which you'll measure the angle through which you have rotated your telescope or the grating element or anything else. Okay, good. Okay, from the first to second, from the first to second, and from third to fourth, from the first to second to the third to fourth, what changes do you see? Okay, fourth lo kuda telescope ఆ పొజిషన్ లోనే ఉంది. Okay, third లో ఉన్న పొజిషన్ లోనే fourth లో కూడా ఉంది. Okay, because of the space paucity, they might not have drawn it. 1, 2, 3, 3, 4. Difference between 1, 2 and 3, 4. What's happening? When you see from first to second, what you have done is you have rotated the telescope by 90 degrees. Okay, from the first to second, you have rotated the telescope by 90 degrees. Sir, how do you know how much is 90 degrees? That is why I'll be making use of the circular scale. Circular scale gives you the angular variation. So I'll be making use of the circular scale to see how much I have rotated this, okay, any of the things. Okay, from third to fourth, you see an arrow in the fourth, right? Which says that you got this position by rotating the circular scale and not the telescope. In the first to second, telescope was rotated by 90 degrees. And from third to fourth, circular scale was rotated by how many degrees? Can somebody tell me? 5 seconds for that. From third to fourth, circular scale was rotated by how many degrees? 5, 4.
45 degrees.
Excellent, 45 degrees. Okay, so we rotated this circular scale by 45 degrees. Now, what is the angle between the grating element and the line that is going into the collimator? Actually, that is okay. Collimator, okay, from collimator you'll get the light and not. Okay, so you're getting light from the collimator. So, what is the angle between the light incident on the grating element and grating element? 5 seconds. 5, 4, 3, 2, 1. 90 degrees. Ante. Understood or not? Okay. Now let me explain the thing. Okay. Okay. Wait a second. Okay. In the first figure, we place collimator and telescope. Collimator is nothing but a device that gives you a parallel beam of light. Collimator gives you a parallel beam of light. Telescope is usually adjusted to receive parallel beam of light. Okay, when the collimator is giving you parallel beam of light, and if the light is passing through the telescope and matching with the cross wire of the telescope, that means telescope and collimator are at 180 degrees. Straight line, that's what you see. Then what do? You will rotate the telescope from its present position of step 1 to step 2 at an angle 90 degrees. That means you will be rotating the telescope by 90 degrees. After that, you will place a grating element such that the light coming from the collimator is reflected into the telescope. Sir, earlier also you have that line, no sir? Yes, you have the line, but there is no possibility of light from the collimator. Light from the collimator will go straight line, right? In the dotted direction. Okay, why will it go into the telescope? No, it will not. So what will I do? I'll place a grating element. I'll place a grating element such that the light gets reflected into the telescope. Step 3. Okay, light gets reflected into the telescope, again matches with the crosswire. That means at the center. That implies now the light has taken a 90-degree turn. When it has taken a 90-degree turn, that means angle of incidence is 45, angle of reflection is 45. So this is 45 degrees angle of incidence of light coming from the collimator on the grating element. What will I do? I will rotate the circular scale by 45 degrees. I rotate the circular scale by 45 degrees, because of which now the light coming from the collimator will be falling normally on the grating element, normal incidence. Okay, so 1, 2, 3, 4. These 4 steps are for normal incidence. Okay. Now after that, 5 and 6 are not required. Okay. Instead, you can draw this one. Okay, now what's happening? Okay, the right side collimator got to left side, that's it. Okay, and this is the grating element, and the light from the collimator is falling normally on the grating element, and it is getting diffracted. When it's getting diffracted, you will get central maxima and either maximas and other maximas. If it is a monochromatic light, all these things will be of the same color, but if it is a polychromatic one, okay, you will have different colors here. Okay, so this is the central maxima. Okay, first order maxima, second order maxima, third order maxima, fourth order maxima. Like this, you will have different maximas onto the left side, and similarly you will have different maximas onto the right side, left side as well as the right side. Okay, so what do? You can rotate your telescope, but not the grating element and the collimator. Okay, so you'll rotate the telescope once completely extremely to the left onto the red color. Take the CSR and Vernier coincidence for red color, and then go to the yellow color, take CSR and VC, and for green color CSR and VC, and for blue color CSR and VC. Blue will be okay over here, and then next go to the blue color here to the right side and take CSR and VC, and then green color CSR VC, and yellow color CSR VC, and again the last, okay, that will be red color CSR and VC. Okay, then what do you get? The difference between the red on either side, that will be 2 theta from the original direction. Original direction deviation is theta, and 2 theta to the left and theta to the right. This is 2 theta for red. That's what you'll get. Similarly, 2 to the right, okay, yellow, green, and blue, and from that you'll get theta values. And using these theta values, you can find out lambda value using the diffraction grating equation. What is the diffraction grating equation? That is d sine theta is equal to n lambda expression. Okay, what is the expression? D sine theta is equal to n lambda. Okay, using that expression. Okay, using that expression, you can find out wavelengths for whatever okay things you want. Okay. Okay, what do we have? We have d of sine theta and theta is equal to n lambda. Okay, so d, how did you get this d? D is the distance between two adjacent slits. So how do I get this? Okay, I'll try to find out what is the total number of slits you have and find out what is the distance between two adjacent slits. That will be D value, so that you can determine from the grating element. Theta, you from the experimental value. N, okay, you have to check whether it is first order, second order, and so on. Okay, usually in our lab we will be doing only for the first order. So will equate N is equal to 1 and find out the lambda. Okay. So you can find out lambda for red, lambda for yellow, lambda for green, lambda for blue, because you'll get thetas for those different colors. Okay, that's how you'll make use of this diffraction grating experiment.